What is up, developers? I have a really cool project to share with you today, and it is this orbit simulator. We will, in the end, have this slider where you can change the eccentricity of the orbit, and we will simulate realistic speeds using Kepler's law. And so, let's look at the geometry we're going to use for this. We're going to set up our nodes in spritekit using these parameters, and then we're going to use the radius formula to figure out where on the ellipse the Earth should be. And finally, we'll use Kepler's law of the ratio of areas to time to realistically determine the speed. Let's open up Xcode and start a new project. Choose macOS and game. Let's call it planets and leave these unchecked. And we want to use spritekit. Let's do some cleanup. Delete the hello world and game scene. Let's change the anchor point to 0, 0. Go to game scene and remove all this junk. Next, let's make our planets. Make a new function called add nodes. Set planet equal to sk shape node, circle of radius 10. And the sun will be sk shape node, circle of radius 20. And make sure to color them. And the sun will be yellow, which is just red and green. Can remove their line width. And put the Z position of the Earth to 1 so that it will overlay the sun because the sun is bigger. So we'll see them both once we add them. Let's add them to the scene. And call add nodes. Let's build and run. And there, down there in the bottom left, we can see the blue Earth on top of the yellow sun. Now next we want to add an orbit path. And for this, I'm going to copy some code I made before that makes the orbit stay in the frame. And I don't know if this is the most neat way to do it, but this is how I have it. And it needs some variables, which we'll just set to 0. CG float. Okay. Now make my node. And in add nodes, let's say path is equal to make orbit path. Self is the scene. And the eccentricity, let's just say 0.1. And let's add the path. And there it is. There is the elliptical path. And ignore this, I made a new project, but Xcode bug makes it so that this appears. You won't see that. We're going to add that later, and it doesn't work anyways. And this is good, but now we need to position the sun on the focal points, one of the focal points of this ellipse. And then after that, we need to position the Earth on the path as well. So how are we going to do that? We need to make a function, or actually in add nodes, we could position the sun at that focal point. So the geometry is, let's start by just saying sun.position is equal to path.position, and let's see what happens. Now the sun's at the center of our ellipse, but we want to shift it over by an eccentricity times alpha, which will be the focal point position. So let us add some code here for positioning. We go to sun.position.x and make it path.frame, and we want to convert this to or we also want the eccentricity. So let's go ahead and make that variable var eccentricity is a float and is equal to 0.1 for now. Let's make that here, and cg float eccentricity times path.frame dot width divided by 2, and that should do the trick. I need to convert this to cg float. And it's hard to see, but we could up the eccentricity, and then we will notice that the sun is at the focal point, so it worked. Next, we want to get our Earth on the path based on the Earth's angle with respect to the sun, and also we need the radius calculation to make sure the distance is right. So let us go here and let's make a function radius this, so epsilon alpha and the angle it takes in, and now we want to position the planet based on this radius. So let's make a new function called move planet. We want it to take in time change and a planet and an alpha and an eccentricity, and the symbol is epsilon, so that just EP. Okay, we need to grab the path self dot nodes, child nodes with name, and we want it to be the path because that's what we named it here in this makeover path function. And we need to define body, which will have just one difference from an SK shape node, and that's it will contain theta. Okay, get this offset that we had before. So let offset equal the eccentricity times, and I guess we should probably change this to be safe, and else fail error node path node is missing. And And now we want to use this. We have the offset now. And that will be the origin. Now we just need the angle and the radius. So let new radius equal to radius calc. And we'll take in all of this. Planet.theta. And also we need to set our new x position is the cosine times the planet dot theta times the new radius, and the new y will be the sine of the planet dot theta times the new radius. And now we can set the position. Planet dot position dot x equals new x minus offset, and we need to first make sure we're starting at the path of path dot position dot x plus new x minus the offset, and we want to do planet dot position dot y is equal to the path dot position dot y plus the new y. And I need to make sure to convert these. And the build is working. We want to go to update and move our planet. Move planet, time change 0.05. Planet is the planet, and the alpha we need to figure out in a moment. This is just the eccentricity. All right, and I'm going to get the alpha function. So this is our get alpha function, which just gets alpha from the geometry of the path. So we go here to let's see, do I have to change? I think a good way to do this is probably var alpha path, because alpha is a property of the scene too, so I don't want to use that variable, is float, and it is return path. Let's do get alpha, eccentricity, and path. Let's see if that works. Let's see. Maybe make this and now alpha path we put in there as body. Oh yeah, we can just change planet to body, and change this to body, and that looks good. Let's see if that works. All right, I have the Earth is positioning right, but our theta or our time is not changing. So, oh, I think I know why. We go to move planet, and we want to, after all of this is done, do planet dot theta plus equals time change. Could have named it theta change, but. And it's working. Look at that. And it's going pretty fast. Thanks so much for watching. That was it for this episode. In the next episode, we'll set up Kepler's law and this eccentricity sliders can change the ellipticalness of the orbit. Leave a like, subscribe, leave a dislike, let me know what I can change. that's it all for this episode. Later.